23rd is going to be your test. And we had so much cool stuff that we learned. And we had a few things that we may have forgotten that. Today I'm just going to recap on the basic things that we have learned. The test that's going to come on 23rd is, some of it is the things that you learned on the first day. Where we talked about the lasagna, you remember? We said that we have an oven. It's the function that we have learned.
So it's going to be, is this test sort of, sorry, is this test going to sort of be part of unit 1, unit 2, and unit 3?
No, just the functions and the inequality that we have learned. Very small concepts.
How many units have we done?
3.
One?
This is our third.
It's the third one.
We're doing it.
How many units are there?
Yes.
So for example, we have 3 tests for the first time.
We're only doing 30% units.
Yes.
We're basically doing every unit a month.
So
There is some weighting that you have to calculate that. How much contribution from each test based on
like 40 and 20.
Yeah.
But do, okay.
Between brothers.
Yes.
No.
Yes.
Is it okay if you like post the syllabus for this year's class?
I have done it in the beginning.
No.
No?
Yes.
Yes, he has.
Why
I have done it.
So no, I checked out the classroom. I didn't find it.
Okay, I'm gonna do that.
Why do you need
Also,
to
we
do
need
this?
to-
Why would
Can
I?
you post their vision sheet for the
Please,
class on
For this coming test? Yes.
So wait, I didn't even know like yeah. Can we like a review class? I didn't even know
Yeah,
what
we need Yes, guys, listen. The things that I'm just gonna cover today is essentially a kind of a review. Then the next session that we're gonna meet, I'm just gonna introduce a new topic to you, which is gonna be relevant for the test. Then please listen, the things that we do today is a kind of a warm-up that when we just meet next session, you are just gonna build on. Now, if you remember, on the very first session when we discussed, we talked about a concept. We just started the course and we talked about the concept that we said it is a function. In the function, we talked about that, and that's going to be essential to what we're going to on the test. And you see that this on the test is much easier because it's a very short off on the particular. If you remember, we said that. We said that we start to introduce a simple variable, and you said that you want to design a function, and you call that a function. We may have something in the form of a function, but now today I'm just going to specify something as we also do that. You said that you see, for example, we design a function with one single variable, which is going to be x, and we say that sometimes we say a linear function. We say, for example, 2x plus 2. It can have many forms. We have seen, for example, the rational functions, the quadratic functions, many forms, but in this one I just want to remind us. We say that when we talk about the function, which represents a transformation of the single variable, you say that, okay, I'm just going to start with 3, for example, with x. Then I put that into a machine, and the x is going to be transformed to 2x plus 2. That's what how we learn the concepts of the function. We say that, okay, if we have, for example, we call that the Venn diagram. We say that if I say that to Lisa, for example, this is going to be the domain, and this is going to be a range. We have had that concept before. We say that when the function is transformed as a function, it's going to be written here. It says that f of x is equal to x plus 3. What we say that? Imagine as a part of the domain, I put the other 2. When 3 starts to just go through the machine, we get it here 1, 2, 4, 7, 3.
Oh, I get it.
The domain is a transformation.
Yeah.
The domain is a plus 3. Now, look at this. Now, because we have multi-solid functions, we try to calculate the range and range. Now, these things make no sense because we have multiple complex functions. But the thing which I just want to highlight here is this. If you remember, we said also we can show that transformation. You said that, okay, I don't want to do this. I don't want to, for example, put the signal, put some moment there, call it domain, and look at the transformation result mapping and say that I'm going to call it the range. I'm not going to do that. But that is going to be so much time consuming. Then what I want to do is that I simply know how to plot it. For example, if it is 3, you see that the plot is going to be this. You say that the plot x is 2x plus 3. Okay. Yes.
So again, just to make sure, you said that, so we have on the plotting graph along.
How do you do that for the test?
So you can just, so if you were to ask, like, you were to describe, you just show the line, just like them to draw a line.
No, you don't need to graph anything on the test.
You're just doing this like.
I should have the illustration. You can look at the test. You should be positive. Yes.
So now we're going to do the
But the math is that. But the thing that you must need to know on the test, and also in future when you talk about the function is this. I'm just going to remind you of something. You see that when we show the functions, I remember on the first session when we talked about this, yes, we said that when we talked about the function, I got an example, I said that this was lasagna. And you said that you have some ingredients, and you put them inside the oven to make the lasagna. And the thing is that, imagine that, if you have, for example, a mushroom for the lasagna, you cannot make one, for example, a mushroom as one single ingredient. You cannot make also pizza. You can make only lasagna. And what does it mean? That it means a lost pizza. Yeah. And now what does it mean? I want to translate what I said to you when it comes to this problem. What does it mean that if you have one ingredient, you cannot have two transformations? It means that, for example, if you have one tree in the function, you only can correspond the definition with one single number, which is going to be how much? 1. We cannot have, for example, 2 also transforms to this. It's impossible. Each ingredient of the lasagna makes only one lasagna. What does it mean when it comes to the quality? It means another thing. If I have one ingredient here, which transforms to only one new corresponding transformation. It means that if you look at, I should say, if you look at the plot, you do not see, for example, this is called the vertical line test. You had it before. If you draw a line vertically, which means that it says, for example, longitude, if you put your ruler here, you draw a line. It should only cross the plot with only one point. If your function is like this, let me put it like this. It's just is it very simple as that's you don't need to plot anything with us? Just a vertical line. For example, here, look at this. You have f of x, you have x, and now I plot the function like this. This is not f of x. I don't need to have to plot that. I don't need not that to learn how to plot it. But I know that if I plot that function, it's just the graph of that function. And the question which I ask myself, and you type on the test is that this plot, which represents that function, is the function itself. And you say, oh, what is another degree? You say, okay, I'm just going to draw the vertical line.
This is the C of a function.
It's in the plot represents the function. You see that if you draw a vertical line, you have two distance. You got, for example, you can call this one A, you can call the other one B. So what does it represent? It means that you said here, you said that if you have one ingredient, imagine that X here is the mushroom that we talked about. With one single mushroom, you were able to build one lasagna and one pizza, which is impossible. You have to ingredients only for one recipe. That's right. Indivisible. Because that's what it's for. Because it crosses 2 points after function. If you are a vertical line, it should only cross the function at 1 point. If it is 2 points, it means that this is not a function. Yes? Yes, sorry, she was correct. Sorry, yes. This means that one transformation is not a function.
That can be on a test?
Yes, why not? No, it's a transformation, not a different time. Yes, no, line. Only line, only vertical line. Only like this. If it crosses only one point, it's a function. You have one, for example, you have a mushroom, you get only the lasagna. Now, you have the mushroom, you build a lasagna pizza, which is, it doesn't make sense because you have enough mushroom. That's why one ingredient makes one result. Yes. Vertical line, and that only crosses at 1 point. Yeah. Can you also, wait, this is considered under the same point. Sorry, what? This one? It's B. It's A and B. This is not. What else did we do? When we talked about the function on the first session, we talked about, for example, these type of functions. We said that f of x equals to, for example, x plus 2. That's right. We said that for this, we said in order to find if this is find the domain of this function, what do you do? We said that you take this one, you imagine that the list of the function should not become 0. We said that x plus 3, if it becomes 0, it means that what? X has to be minus 3. And in that case, it takes the basement of the house will be higher, and that's what we have to avoid. And as a result, we decided to define it away as a set. Since all the x can be belonging to the order of numbers, however, x should not be equal to minus 3. Because if it's minus 3, it's on the basement, it sets the fire, it sets the house on fire, and that's what we have to avoid. We talked about that before the second test. Now, to say that we want to expand this method, we have to talk about something else. Well, this is one type of the functions which you define in the domain. We say that now, if you have another form of the functions like this, we say that the x can be something under the same rate. For example, we say a function, something very easy. We say that, for example, 2x plus 16. What is this minus 2x plus 16? Is it more than the square root? Here, that's essentially, that's part of the main part of our review today. What did we say when that time? That time about this? Yes, please, my debate. Next session, yes.
Sorry, I better ask you a question about the math.
Oh, okay, well, okay, so that's. So, by the way, okay, please, next session, and help you in your calculators, practical calculators.
I always have
Don't worry, I'm gonna, if you do not have it, I'm just gonna give you, at least make your laptop. define the domain represents all the x's which belongs to real numbers. However, x should define the array that g of x has to be positive or equal to 0. That's how we define, before we just go to our November there, how to find the domain of these three functions. Now, I look at this function. When I look at this, I notice that minus 2x plus 16 on 0 represents another function, like g of x. Now, if you want to apply, I said that one of the terms counted to some real should only be greater than or equal to 0. That's why we find the domain, which means that 2 minus 2x plus 16 should be greater or equal than 0. Now, when you look at this, because we start off with the pattern, this is an inequality. The linear inequality, and what we have to do, we have to solve it. We have to see the range of the x. Now, in order to solve it, I think that we should have made a strategy. And the strategy is that I'm just going to keep not solving the function. Keep x at one side of this inequality and take the others towards the other side. It means that I'm going to put minus 2x here. If I have the direction of the inequality intact, then plus 16 minus 6, that's right here. Minus 16. Now, and that's the part which we do a kind of magic. And it's what? That's right. Because that's right. Look at this. Minus 2. I have to isolate because we have another 2 steps method. The first step method was that. The first step method was that we said that first, we take the x on one side, the non-variable to the other side. The second step was to isolate the x, which means that I have to calculate one of the coefficients. But the coefficient is negative, and that was a thing that we learned in magic. The first changes to the sharp, and now if I divide both sides by minus 2, it becomes x minus 2 divided by 2 becomes 1. Then I have x. Now, I flip the direction of the inequality, and minus 16 over minus 2 becomes 1. Okay, 8, 100 plus 8. And now, at this stage, we can define the domain like this. We have two options. The first option to show the domain is this. I say, okay, I'm just going to say the domain is the x, which is all the real numbers. However, x has to be less than plus 8. That's the first method which I can just use to solve that domain. The second method, which I said, I'm just going to draw it here. The second one was that I say, okay, I'm not going to use the set, but I'm going to use the intervals. What does it mean to show it on an interval? It means that, first of all, guess this. You're good? No? What does it mean the interval? It means that I draw the x, and the x-axis, of course, comes with an origin. Now, I localize that point, plus 8 is going to be here. And also, I told you something. That I said that, imagine if you are standing here. For example, this is now, for example, Matthew are standing on top. Now, look at this. If Matthew walks along this direction towards the right, the x is going to be here and here and here. But if Matthew decides to walk towards the left, it is getting smaller, smaller, and smaller. And that was the thing that we said. Now, if you are looking to show that x is less than 8, after localizing the x, okay, on the x, I'm just going to show, first of all, I'm just going to show a circle. If I have less or equal, it means that the circle I have to fill this as a result, this direction is the thing we are going to choose. Yes. Yes, please. Yes.
So because Tom was showing that only be out of the control if you realize
Yes, sir. Because also, slowing down zero is that simple.
okay, so you should show every and if you get a office or if there happens to be something on the line, you should always put a color in the ball, right?
That's right. And now, that is so lucky.
Thank you very much.
Any questions, Michael Williams?
I know. Like, what are your? I'm going to. I'm not going to post it. Yeah, I think it's happening. I'm very nervous about that. I want
Okay, now, I'm just gonna, hold on a second right now. I'm just gonna,
You spent 5 minutes going outside, coming back.
Right.
Look at this, listen now. Guys, I'm gonna explain this to you. This is a very easy concept, but you may have it on your test. Then please take a look. The first one on the top. Let me put that also on paper. What time is it now? The period ends by 4, huh?
Oh, yeah.
I'm finishing 5 minutes.
I go home.
Sorry? Yeah.
1 minute, 8 minutes, 5 minutes.
Guys, look at this. The first one. Minus 5, 1. Minus 5.
Their functions if they only have one result.
That's right.
Oh.
You guys, look at this.
No,
For the first one. For the first one, guys, everyone, now look at this one. The first one, I'm just going to do the first one, the rest of it is going to be easy. Look at this. If you have a set of some pairs, we call this a set, and these are a pair because minus 5 and 1, they represent what?
What is
One on the draft
Order.
information plan.
what is it? It's easy and slow.
No, the guy from Top Mustard.
Look at this. Now, I'm going to show that the same elements within a Venn diagram. Every first element here, it shows what? X. The second element shows what?
Y.
F of X or Y. Then I should put minus 5. Over here, I have
Is it the domain range?
minus 1. That's right. 1. And the second one, the second element shows what? The
Y.
range.
So that's that.
1, 2, 3, 2.
1, 2, 3, 2. Now, and now I know that minus 5, minus 3, minus 1. 1, 1, 2, 3, 2. And now, in order to show the transformation, I connect them together. I know that minus 5 is mapped into what? Minus 3 is mapped into 2. Minus 1 is mapped into 3. Minus 1 is mapped into 2.
I mean, you wrote 2 twice. So you just wrote it once there.
Which one?
There's 2. You wrote the number 2 twice.
I have a question.
It is 1,
This 4.
2,
And you just write 2. You just write 2 once.
No, she's not.
I have a question.
Yes.
How come there's, I was
How come what?
here.
That's a C.
This one?
That's a different question.
That's difficult. I'm just going to
Why? I have a question.
Yes.
In the picture over here, the 3 and 5 are positive, but the other right. Oh, it's just a, yeah.
Now, I'm gonna go to solve the second one.
How do you solve that? Just
And
do that?
good for you, you're gonna finish today like that.
How did, that's what you did to solve it?
That's right. The first one, guys, look at this one. The first one, it means that this is a function. Because for each element, there is only one corresponding element there. Now, look at the part C.
I don't understand
Which part?
everything.
Listen harder.
Wait, why are we going
You
to?
should
Wait,
get
but I thought it can't work because you're sitting there.
Wait.
But you drag it back.
No,
The
but
first one is not a function.
It is a function.
It is different. It is.
No,
Guys, I'm gonna show you the next one.
It is.
I'm confused. I
Okay, now.
Yes, exactly.
Yes, no. Yes, no.
Let's, guys, please everyone follow. Now, for the second part C, now okay, when I explain this one, you see why that thing is a function. For this part, I connect these ones. The first element 0, 3, 5, and 0. And also I have 4, I have 5, I have -2, and I have 1. Look at this one. 0 is connected to 4, 3 is connected to 5, 5 is connected to 2, and I have 0. 0 is repeated twice, then I don't bother, I just write it like this.
So why don't you do that in the y-axis over there?
Which one? You have the same question?
Yeah, so 2 is repeated twice, so why don't you just make it only 1, 2 there?
Yeah, you can also do that. Now, but look at this now. And hey, listen. Anyone listen? Now, what is the problem with this one?
There's,
Yes.
you only have 3 mushrooms, not 4, so the mushrooms are not
That's so true.
going
Right now, for the first part, guys, look at this and take everyone. Everyone
Wait,
listen.
if you,
Listen, everyone.
if you make the, if you erase the two, won't that affect the answer along?
No. You just erase 2 and you just have the 2 arrows going to this. It doesn't matter.
So those can,
Oh,
so the
yeah.
difference between that one and that one, if we were to summarize, sort of, it would be, this,
So
this,
Guys,
listen.
so, why are you talking?
I feel like
Let me explain. Guys, everyone, let me explain. Guys. Listen. I explained that to you at the beginning of the course when I showed that to the graph. And now, look at this one. This one is the same thing. I said that to you when you are having the domain and the range. If you have a domain and range, I said that when you have, for example, if you remember when I discussed that over the plot, I said that this is a function. I said that if you have a vertical line going through this, the vertical line should not cross more than 1 point on the graph. Then as a result, this one, we see that this is not a function. What this represents, it means 1x, 2 different y. And Kate, look at this. If you learn that, you look at this one. We said that there should not be 1x and 2y. Look at this. We have 1x and 2y. That's
so that
why.
means both B and so B is not a function.
B, you mean
C is not a function, yeah.
C. No, this one is C.
Yeah, but like also B is not B is not a function.
Yeah,
That's
you're
right. If you look at B also, B is not a function again. Because we have 1x, Janaya, and we have 2 different y's, which is
So
exactly
A is also not a function.
A is because
why is
Why
A
is
a
it-
two X's and one Y. Not,
instead
so it's not, it's 2 X's, 1 Y, no
If
difference
you
in
say, for example,
yeah.
Lucas,
Oh, okay.
you say that, you can't look at this. Everyone, Lucas, man. say that I have two elements there. Let's save some space, erase the first, and instead, one I map it going to the same bar. The same thing. It doesn't matter. Now look at this. You say this is a function, but the other one is not. What's the difference? The difference, yeah, give me one second. The difference is this.
Okay.
We said 1x gives 2y. That's the problem, because this is the problem. Now, this one, you have two different x, one y. It doesn't matter. And if you go back to the concept of the lasagna, this one you say that, for example, this is a mushroom, sorry, the -3, that they are mapping into one number. You say -3 is a mushroom, and 1 is pepperoni, and both of them gives one food. And so, but not here, look at this case. You have only one mushroom, gives either the lasagna and gives pizza, which is impossible because we do not have enough mushroom. That's the analogy which I use. But in terms of the math, you say that there should be no 1x that gives you two different y's. If it gives you, this is not a function. Like this example. 1x gives you two different y's. This is not a function.
I understand.
But now, over here, we have two different x giving you one y. Like this. What does it represent, everyone? Look at this. For example, look at this parabola that we worked before. We have, look at this y here. We have one y with two different x, x1 and x2. But this is a function because the vertical line, it doesn't cross that function over 2 points. Now, then you see that for that case, we have two different x corresponding to one y. This is a parabola, and that's a function. Because if you draw a vertical line, it doesn't cross into 2 different points.
Even though there is 2 different ones, right?
That's right. Make sense, everyone?
Yeah.
Now,
Yeah.
we have no